97% of companies using Kubernetes never scale beyond their original expert team, and it's not a skills problem.
Wait, if it's not skills, what's keeping them stuck? So we're uncovering why IDPs are mandatory, what they actually abstract away, and how to implement one?
By minute 4, you'll know if your Kubernetes setup is scalable or doomed. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into why IDPs are the only way to scale Kubernetes beyond experts.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's been bubbling up in every platform engineering conversation I've had lately. This idea that internal developer platforms aren't just nice to have anymore. They're becoming the only realistic way to scale Kubernetes beyond a handful of experts.
Yeah, I've been seeing this tension firsthand. We've got maybe 3 people on our team who really understand Kubernetes deeply, and everyone else is just copying YAML files and hoping for the best.
And that's exactly the problem. Kubernetes has become the de facto control plane for infrastructure. It's everywhere, but the complexity hasn't gone away. If anything, it's gotten worse as we've added more features, more CRDs, more operators. The latest CNCF survey showed that 96% of organizations are using or evaluating Kubernetes. But get this, 68% cite complexity as their biggest challenge.
Those numbers track with what I'm seeing. Just last week, we had a developer accidentally expose a service to the internet because they copied a manifest from another project without understanding the networking implications.
And that's a security incident waiting to happen. But here's what's really interesting. This isn't a Kubernetes problem per se. It's a scaling problem. When you've got 10 developers and 3 Kubernetes experts, you can make it work. But what happens when you need to scale to 100 developers, 500? You can't hire Kubernetes experts fast enough.
Plus, even if you could hire them, do you really want every developer to be a Kubernetes expert? That seems like a massive waste of their actual skills.
Exactly. And this is where the whole platform engineering movement comes from. Companies started realizing they were asking application developers to become infrastructure experts, and productivity was tanking. I was talking to a platform lead at a fintech last month. They calculated their developers were spending 40% of their time on infrastructure configuration and debugging. 40%!
But wait, didn't we solve this already with DevOps, the whole you build it, you run it philosophy?
That's the irony here. DevOps was supposed to break down silos, and it did. But it also created this expectation that every developer needs to be a full stack plus infrastructure engineer. And with Kubernetes, that's just not realistic. The cognitive load is too high. You've got pods, services, ingresses, config maps, secrets, persistent volumes, network policies, RBAC.
Stop, you're giving me flashbacks to our last incident review.
Right? And that's just the basics. Now add service mesh, GitOps, progressive delivery, multi-cluster setups. The surface area is massive. What we're seeing now is almost a pendulum swing back, not to the old days of throwing code over the wall to ops, but to a model where platform teams provide golden paths and abstractions.
So internal developer platforms are essentially productizing the infrastructure layer.
That's a great way to put it. Instead of every developer needing to understand Kubernetes primitives, they interact with higher-level abstractions that make sense for their use cases. Need to deploy a web service? Here's a simple API or UI that handles all the Kubernetes complexity under the hood.
Coming up, we'll dig into exactly how these platforms work and what makes them different from just slapping a UI on top of kubectl.
So let's get into the meat of how IDPs actually solve the Kubernetes complexity problem. Because it's not just about hiding complexity, it's about creating the right abstractions at the right level.
Walk me through what a developer experience looks like with a proper IDP versus raw Kubernetes.
Perfect example.
Deploying a simple web application. With raw Kubernetes, a developer needs to create, at minimum, a deployment manifest with resource limits and health checks, a service definition, probably an ingress for external access, config maps for configuration, secrets for sensitive data, maybe a horizontal pod autoscaler. That's easily 200 to 300 lines of YAML across multiple files.
And they need to understand how all those pieces interact, plus namespace isolation, RBAC permissions.
Now contrast that with an IDP. The developer might just specify, I need a web service running this container image. It needs a database, and it should be accessible at this URL. That's it. The platform handles all the Kubernetes orchestration based on organizational standards.
But isn't that just a PaaS? Like, how is this different from Heroku?
Great question, and this is where it gets interesting. Traditional PaaS solutions are one size fits all. They make opinionated choices that work for 80% of use cases, but completely fall apart for the other 20%. IDPs are different because they're built specifically for your organization's needs. They can expose different levels of control when needed.
Give me a concrete example.
Sure. Let's say you're at a financial services company. Your IDP might have 3 tracks. A simple service track that's basically Heroku-like for internal tools, a regulated service track that automatically adds audit logging and encryption at rest, and an advanced track where teams can still drop down to Kubernetes primitives if needed. The key is that 90% of teams use the first 2 tracks.
So you're not taking away power, you're providing shortcuts for common patterns.
Exactly. And here's where the numbers get compelling. Humatech did a study of their customers and found that teams using IDPs saw deployment frequency increase by 4x and mean time to recovery drop by 65%. Why? Because developers aren't debugging YAML indentation errors or trying to figure out why their pod is in crash loop backoff.
But building an IDP sounds like a massive undertaking. How do organizations justify the investment?
This is the critical calculus every organization needs to make. Let's do some rough math. Say you have 100 developers and they're each spending 40% of their time on infrastructure tasks. At an average fully loaded cost of $200K per developer, that's $8 million per year in lost productivity. If a team of 5 platform engineers can reduce that to 10% through an IDP, you're saving $6 million annually.
Plus the opportunity cost of features not shipped, incidents from misconfigurations.
Exactly. And there's another factor, onboarding. One enterprise I worked with measured that it took new developers on average of 3 months to become productive with their Kubernetes setup. With their IDP, they got that down to 2 weeks. In a tight labor market, that's huge.
What about the technical architecture? How do these platforms actually abstract Kubernetes?
Most successful IDPs follow a layered approach. At the bottom, you still have Kubernetes doing what it does best, container orchestration. Above that, you typically see an API layer that translates high-level developer intents into Kubernetes resources. This might use operators, Helm charts, or custom controllers.
And then the developer-facing layer on top?
This varies a lot. Some organizations go CLI first, others build web UIs. Many do both. The key is meeting developers where they are. Spotify's Backstage is a great example. It provides a unified portal where developers can discover services, create new ones from templates, and manage deployments without touching kube control.
But what about when things go wrong? Don't developers still need Kubernetes knowledge for debugging?
This is where good IDP design really matters. The best platforms provide progressive disclosure of information. Basic troubleshooting shows application-level metrics and logs. If you need to go deeper, you can access pod status and events. And yes, for that 5% of cases, you might need to drop into kube control. But by handling the 95% gracefully, you've still dramatically reduced the burden.
Stick around. We'll give you the exact framework for evaluating whether your organization needs an IDP.
So let's get tactical. How do you know if your organization actually needs an IDP? Because let's be honest, not everyone does.
What's the threshold? When does it make sense to invest in building one?
I use a simple framework. First, team size. If you have fewer than 20 developers, you probably don't need a full IDP. You can get by with good documentation and maybe some Helm charts. Second, deployment frequency. If your teams are deploying less than once a week, the ROI might not be there. Third, and this is crucial, technical diversity. If everyone's building similar services with similar requirements, you might not need the flexibility an IDP provides.
What about the build versus buy decision?
This is where the landscape has really evolved. 3 years ago, you pretty much had to build everything yourself. Now you've got options. There's the pure DIY approach, take something like Backstage and build your own plugins. There's the platform approach with tools like Humanitech or Sheepa. And increasingly, cloud providers are offering managed solutions. AWS has Proton, Google has Anthos Config Management.
But those vendor solutions lock you in, right?
It's a trade-off, like everything in tech. The vendor solutions get you up and running faster, but yes, there's lock-in risk. The DIY approach gives you complete control, but requires significant ongoing investment. Most organizations I see succeeding are taking a hybrid approach, using open-source components where possible, but not being afraid to buy when it makes sense.
What about organizations that already have some platform capabilities? Where do they start?
Start with auditing what you have. Most organizations have more platform pieces than they realize. CI/CD pipelines, artifact repositories, monitoring stacks. The question is whether they're integrated into a cohesive experience. I recommend starting with one golden path. Pick your most common use case, maybe a stateless web service, and build a really smooth experience for just that.
And then expand from there.
Exactly. Once teams see how much better the experience can be, you'll have internal champions pulling for expansion rather than you having to push adoption. The key is to measure and communicate the impact. Track metrics like deployment frequency, lead time, and incident rates. Show the business value.
What are the common pitfalls to avoid?
The biggest one? Trying to build the perfect platform before releasing anything. I've seen teams spend 18 months building their IDP in isolation, only to find it doesn't match what developers actually need. Start small, iterate quickly, get feedback constantly.
It's like product development.
That's exactly what it is. The best platform teams think like product teams. They have roadmaps, they do user research, they measure adoption and satisfaction. The second pitfall is making the platform mandatory too early. Let teams opt in, prove the value, then gradually make it the default path.
Looking forward, where do you see this going?
I think we're going to see IDPs become as standard as CI/CD pipelines are today. In 5 years, the idea of giving developers direct access to Kubernetes will seem as outdated as asking them to manually SSH into servers to deploy code. We're also going to see AI play a bigger role. Imagine describing what you want to build in natural language and having the platform generate all the necessary configurations.
That would be a game changer for productivity.
The real insight here is that Kubernetes won because it's incredibly powerful and flexible, but that same flexibility makes it too complex for most developers. IDPs aren't about dumbing down Kubernetes. They're about providing the right interface for the right user. Your platform team gets the full power of Kubernetes to build robust, scalable abstractions. Your developers get a simple, safe way to deploy their code. Everyone wins.
And ultimately, that's what good platform engineering is all about, multiplying the effectiveness of your entire engineering organization.
Exactly. If you're spending more time fighting your infrastructure than building features, it's time to seriously consider an IDP. The question isn't whether you need one, it's how quickly you can build or adopt one before your competitors do. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development in the observability space. Apono just announced their integration with Grafana that brings just-in-time access to data sources. Instead of those static, always-on permissions we've been stuck with, teams can now grant time-bound, policy-driven access.
Oh, that's clever. So engineers only get access to production dashboards when they actually need it?
Exactly. According to Grafana's blog post, it's all about reducing that security surface area. No more permanent access sitting around waiting to be exploited.
Speaking of reducing operational overhead, Pulumi Cloud just dropped expanded version control support. They're now covering GitHub, GitHub Enterprise Server, Azure DevOps, and GitLab with consistent deployment pipelines.
The PR preview feature caught my eye, plus they're adding AI-powered change summaries. That could really speed up code reviews for infrastructure changes.
Now here's something impressive. Netflix just automated the migration of 400 production RDS PostgreSQL clusters to Aurora PostgreSQL. 400!
InfoQ reports they built a self-service platform that focuses on minimizing downtime and operational risk. That's platform engineering at scale right there.
I wonder what their rollback strategy looked like for something that massive.
Shifting gears to AI, MasterCard just completed their first live agentic payment transaction in Singapore with DBS and UOB banks. They're using something called the Agent Pay framework.
Autonomous AI conducting financial transactions. That's either brilliant or terrifying, maybe both.
And speaking of AI agents, Gizmodo reports that NVIDIA is developing their own answer to OpenClaw, potentially setting standards for this emerging AI agent platform space.
Let's talk security patches. NAT's server just pushed out 2 critical releases, version 2.11.4 and 2.12.5. Both address CVE 2026-29785, which affects systems with leaf node compression enabled.
There's also CVE 2026-27889 for WebSocket-enabled systems. The 2.12.5 release includes dependency updates like the latest N-keys and compress libraries.
If you're running NATs with either leaf node compression or WebSockets, you'll want to patch immediately. These are security releases, not feature updates.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.